Alright, and here we are in our first diode video. I know it's been a little while and I apologize, but we're going to get right into it. So we're going to start with what we know about what we see on the screen. So we see two simple DC circuits, both series. They both have a diode and a resistor and a voltage source, but the orientation of the diode is different in the two examples, and we're going to talk about why it is there specifically so that we can talk about how diodes work. These are actually very simple junction diodes, and junction diodes, they just allow current to flow in one direction. It's a very common type of diode. Alright, so we're going to look first at our voltage sources. Now, we remember from our previous videos that the small lines are the more negative and the big lines are the positive. And there are more positive and less negative. Okay, so when we look at the orientation of the voltage source to our diode, we see the negative leaves the power source and goes to, it will encounter the positive side of the diode. Now, that seems like it would be a good thing because typically we look for the negative to go to the positive. And so that seems perfectly normal. That would be good. But in actuality, in diodes, we want current to flow through the diode. We don't want it just to be attracted to the diode and that's where it stops. And so for it to flow through the diode, this sort of configuration actually doesn't work for us because it is essentially stuck right there. The positive of the anode, which is this large portion right here, this is the anode. And just like in power sources, in diodes, more positive, so the big side is the positive side. And this little bar right here, the small side, that is the negative side. So in actuality, we have a situation where the positives, the holes in our positive portion of our diode, our anode, are attracted to the negative and the negative to the positive, and they just go nowhere. They are attracted to each other. And if you remember from what you learned in class, that depletion region in the middle, that spot in between the negatives and the positives, actually gets larger and larger because the two bodies are going away from the center towards what they are attracted to. So this right here, this one over here, in fact, I'm going to throw up the positive and negative for our diode. That circuit shows what we would consider to be a reversed bias diode. In other words, it is against the bias. Right? So the bias is to have the negative flow through to the positive side of our power source, and it's not doing that. So this is a reverse bias diode. It has been put in backwards, either deliberately or by accident, because many diodes are put in reverse biased on purpose to stop current flow. Okay, so let's look over here at the one on the right. Okay. Now we're going to put our voltage source indicators up again. And we're actually going to put our diode indicators up again. You'll remember we are more positive, so the large side there, the anode, is the positive side, and the little bar there is the cathode, which is the negative side. Okay, now on this example, we see that the negative portion of our power supply is encountering the negative portion of my diode first. So that is going to drive, so the negative is repelled from the negative of the power supply, and because it is repelled from the negative of the power supply, it is repelled towards the positive of the diode. And so, and we're going to talk about it in just a minute, provided you provide a little bit of voltage that will overcome the depletion region, which is very small, 0.3 for germanium and 0.7 for silicone, current will flow over to the positive side of the battery. So this is called a forward bias diode. And you will notice the difference between the two is the forward bias diode, you see like to like. So if you leave the negative side of the power source, you encounter the negative side of the diode. If you leave the positive side of the power source, you encounter the positive side of the diode. Now, on your reverse bias, you'll notice that it is unlikes that are connected. So the negative of the power supply is going to the positive of the diode, and the negative of the diode is connected to the positive of the power supply. That is a reverse bias diode. So on the left, on the circuit on the left, we have a reverse bias diode, and the circuit on the right, the circuit on the right is a forward bias diode. Okay, let's see. Oh, and this voltage drop, now this is a constant voltage drop. The silicone always has a 0.7 voltage drop and the germanium a 0.3, at least for the purposes of the course that you were going through. Now, this is very important. This voltage drop does not change, and we're going to talk about that a little bit more in our next videos, but just be aware that that voltage drop is referred to as knee voltage or offset voltage. So those are the two little terms there that I put on the bottom right of the screen. All right, and we're going to go into some calculations next.